Hello there. In this knowledge module, we will try to solve a very simple annuity question from the topic of time value of money. So this is the question right in front of my screen. It is written that suppose you invest 300, you need to invest $385 at the end of each of the next 8 years. If the interest rate is 7% compounded annually, means the interest will add annually. So once a year the interest will be added. Then how much would be the investment, the worth of the investment after 8 years of time period, given in part A, if the investment is happening at the end of each period. Remember, the period over here is the year, right? And in part B, what would be the worth of the investment if the investment is happening at the beginning of each period? Again, the year over here is a year. Period can be anything, and we will see different questions where instead of the interest being compounded annually, it might be compounded semi-annually or quarterly. So we have to do a relatively different treatment over there. But over here, let's start with the very basic thing where the payments are happening at the end of the year, and in the second scenario, B scenario, the payments are happening at the start of the period. So if you see we have over here, let me just give me a second. I have to select the pen. So this is the timeline, and in the timeline, this is the period right now. It is year. It is the start of the first year, or you can say that this is the end of year zero. There is no year zero, but it symbolically means that this is the time right now. After the end of the first period, means after the end of the first year, there will be this first deposit happening over here, then second, then third, and so on until the eighth period will be over. So at the end of the eighth period, the last eighth payment will happen, 385. So we can see that because there is equal payments and the payments are happening after fixed interval of time after every year. So this is the example of the ordinary annuity, and might be either the person is himself interested to deposit. Maybe he wanted to save some money for some future expenses, so he has decided to deposit equal amount of money after fixed interval of time. And if the guaranteed interest rate is 7%, say 7%, then he wanted to know that what would be the worth of all this investment at the end of the eighth period over here, right? So one way is you individually compound the interest or calculate the interest. So for example, the first period, if we will compound the interest, how many period it will basically the interest will be added to it? If you see, it's 7 years, because total there are in total there are 8 periods, but for the first period, this period, the interest will not be added, and the first payment will has the opportunity to earn the interest for 7 periods. So this will be the first period, second period, third, fourth, fifth year, sixth year, seventh year. So 7 interest will be added. So how can we find the future value of this 385? Simply, the future value will be after 7th period, because it has the opportunity to earn the interest for 7 periods. It will be the present value 385 multiplied by 1 plus the interest rate. 1 plus the interest rate. What is the interest? 7%. In decimals, 7% is equal to 0.07 raised to the power 7, right? So whatever will be your answer over here, you'll find the answer. In fact, let me do it on the calculator right now. 1.07 raised to the power 7 multiplied by 385, right? So it is $618 and 0.23, right? So this would be the worth of 385 at the end of this 8th period. But remember, even it is 8th period, but the first payment has the opportunity to earn the interest only for 7 periods, right? In case of the ordinary annuity. Likewise, you have to find the future value of each and every cash flow over here. So this 385, obviously, we will have 385 multiplied by 1 plus the interest rate 0.07 raised to the power 6, because this has the second cash flow in case of the ordinary annuity has the opportunity to earn 6 interest rate. Now likewise we have to do all of them, and once we'll calculate their future values, we add them and we'll be able to find the answer over here. But as you can see, it's a very lengthy and time consuming process. So the good thing is that we have a formula, so we can use the formula, and I'll show you the formula. But in second case, in the second scenario, all these payments are happening in the beginning. So it's a fixed, it's an equal payments which the individual is doing. It's basically he's doing the saving. He's foregoing his consumption to have a more money at the end of the 8th period. So now the payment is happening in the beginning, but after every fixed interval of time, at the beginning of every beginning of every period, he'll be depositing 385. In that case, what sort of annuity it is? It's the annuity due. And in annuity due, each cash flow has the opportunity to earn the interest for one more period, right? So for example, if you see, these arrows are showing that in case of the A scenario, in case of B scenario, instead of A, the first cash flow, rather at the end of the first period, it is happening at the end of 0 period, means right now, right? Over here, this arrow is showing this thing, right? So over here, the second cash flow, which was happening at the end of the second period, actually is happening at the end of the first period in case of annuity due, right? This is the part B of this question, right? Likewise, the last eighth the cash which the money deposited at the end of the 8th period in case of scenario A, in scenario B it is getting deposited at the end of the period 7, or in other ways you can say at the beginning of the 8th period, right? Rather at the end of the 8th period, it is getting deposited at the start of the 8th period. So if you see the first cash flow, it has the opportunity to grow by 8 period. So 8 time interest will be added. Every year 1 interest will be added. So 1, 2, 3, 4, 5, 6, 7 and 8, right? Rather 7. So what will happen if I want to find the future value of the first cash flow? What I will do, I will multiply 385 into 1 plus the interest rate raised to the power 8, right? So let's see, it's over here. So future value of the first cash flow will be after 8 period will be 385 into 1 plus interest raised to the power, which interest is, remember, 0.07 raised to the power 8, right? Now, because every cash flow has the opportunity to earn the interest for one more period, you can check with the second cash flow as well. In case of scenario A, the second cash flow has the opportunity to earn the interest only for 6 period. But in case of scenario B, the second cash flow has the opportunity to earn interest for 7 period, right? So in that case, in the similar way, every cash flow will have the opportunity to earn the interest for one more period. So if we can calculate the future value of the annuity, ordinary annuity in scenario A, and we multiply it simply with 1 plus the interest rate, we can find also the final worth of the future value of the annuity due in scenario B. So rather doing each and finding the future value of each and every cash flows, the good thing is we have a formula for that. So let's see what is the formula. So in case of the formula, this is the formula over here written, this one. This is the formula written for the future value of the ordinary annuity, this complete thing over here. This thing, right? This is the complete formula. So what can I do now over here? What can I do now over here? PMT. What is PMT? It's the equal payments. So equal payments are 385. Equal payment is 385. 1 plus the interest rate, which is 7%. And in formulas, you write not in terms of percentage. You actually have to convert into decimals by dividing the percentage with 100 raised to the power 8 minus 1 whole divided by the interest rate. And if you calculate it, you will find it that the answer is $3,950. So and 2 cents. So it means that at the 7% interest compounded annually, if the person is investing $385 after every year, at the end of every year for 8 years, his final worth becomes the future value of all these cash flows, stream of cash flows becomes 3,950.02 in scenario A, which is the ordinary annuity. In case of the annuity due, now if you simply multiply this thing with 1 plus the interest rate, you can find the answer. So this is what I have done on this next line. So annuity due formula is actually the same formula for the ordinary annuity, multiply by 1 plus the interest rate, right? So this is the future value of the ordinary annuity multiplied by the 1 plus the interest rate. This will give me the final answer for the annuity due. So 395.02, which I have found over here, multiply by the 1 plus interest rate, and this will give me 4,226.52. Now, rather what we have understood over here, rather finding the future value of each cash flow in case of annuity, the best approach is to use the formula because it saves time. Now, even if you see there is some calculation involved over here. So another approach is to use the financial calculator, which I always recommend to the students or any person who is trying to find the future value of the annuity, like what I am doing over here. In that case, go on the financial calculator, right? So this is your Texas Instrument financial calculator, which I also use all the time. In that case, you need to feed in these values. First of all, check in case of ordinary annuity, your payment mode is at the end of every period. So go and check that payment mode, right? So second payment, it's at the beginning. So it is set actually for the annuity due. So let's change it to the end, and let's start again. Now n is how much? We know that n is 8 periods. There are 8 periods involved. Strange thing that the first cash flow has the opportunity only to add and have the interest for 7 periods. But remember, this first period we also need to count, because this is the first period after which the first payment of the annuity came, and this is the reason why we have the definition of the ordinary annuity, because most of the businesses deal in such situations, right, where they keep doing the equal payments after a fixed interval of time to any other business, right? So that's why it is usually called ordinary annuity. So not usually called, it actually called ordinary annuity. So let's start with the A, 8N. Now what is the interest per period? Now I/Y, actually it's per period interest, which is 7%. In formula you use in decimal, but in calculator you need to feed in as it is the percentage. So rather putting 0.07, we need to put 7. That's the interest rate. What is the present value? There is no present value. When there is equal payments involved, there is no present value. We'll consider it. We'll consider it as the annuity payments, right? So present value will be 0. So 0 is my present value. What is the payment? Now in formula, I simply wrote 385, but now over here, if I'm depositing, then it is 385 minus, and I will insert the payment. Now, even if I'm depositing it in my own account, but for some time I'll not be able to utilize this money, so it will go out of my pocket. That is the reason it's a symbol. The minus is the symbol that I'll not be able to consume these 385. And once I'll put the payment, now automatically calculator will understand that for 8 next periods 385 payments will happen. Now compute future value, and this is exactly the same answer what we got over here, 3950.02, right? And if I will change the mode of the payment to the beginning, and now I compute the future value. Sorry, I think I need to feed the numbers again. So 8, 7, payment is 0, present value is 0, payment is 385 minus is the payment. First you have to insert the numbers, actually put the numbers, and then you have to press the other things. So, and if now I compute the future value, I got 4226.53.52. When I did it with the formula, I found 0.52, but it's a very minor difference, just a 1 cent difference. So this is how we will be able to do it with the calculator. Now there is another way to do it on Excel, right? In Excel, if we have the same thing over here, n is 8, interest is 7%, future present value is 0, payment is minus 385. I have to find the future values. So future value of the ordinary annuity after 8 period is equal to the present value and rate. What is my rate? 7% is my rate. Number of time periods 8. Payment is minus 385. What is sorry, it should be the future value rather than present value. Right now I'm trying to find what is the future value of this annuities, right? What would be the worth of these annuities, these equal amount of these like this stream of cash flows of equal amounts at the end of the 8th period. So future value I have to find. So future value, so rate, FV rate, and number of time periods, payments minus 385. Again the same concept, I'm not be able to use this 385, so I'll put the minus and 0, and here you go, 3950.02, the same thing which I got over here, 3950. And in case I want to find the annuity due value, I simply need to multiply this ordinary annuity with 1 plus the interest rate, 4226.53. So 226.52.53, again it's a very minor difference, and this is very much possible when you are using the formula, but again it's just a 1 cent difference. It should not be even a difference of $1. It's just a few cents difference, right? So this is the first simple example, one of the basic example, that how we can use the concept of time value of money to move the cash around and can find what is the future worth of a stream of ordinary annuity and the annuity due after a particular time period. I hope you understand this question. If you have any question, you can type in the comments or you can email me if you have my email. Thank you.